Okay, so example 10 asks us to solve the equation 3 to the 2x plus 1 minus 18 equals 25 to the 3 or times 3 to the x. This type of equation is going to cause some problems for us because we have 3 different terms now. Not just 2, we have 3, and what really this means is that we can't make this into a multiplication. It's very difficult to factor this and to make things easy on ourselves. One thing that we can realize, though, is, and the skill that they want you to master here, is to transform an indexed equation, so an exponential equation, into a quadratic equation. So I'm going to explain how this works, okay? So a quadratic equation normally looks, you have ax squared plus b to the x to the first. We don't write that because we don't need to, but it's to the first power. And then we have plus some number equaling 0. So anything that has this form of a square, so some sort of square, some sort of regular version of the function with an exponent of 1 and a constant, we can use a quadratic equation for, and we can solve that way. So what I want you to realize is this fact right here. 3 to the x is just 3 to the x. But if I were to square that, 3 to the x and then squared is actually the same as 3 to the 2x. It's like doubling the exponent. Okay? So some people are always like, oh, that's kind of weird. Well, think about it. Like 2 to the first is 2. 2 squared is 4. But that's the same thing as just doing 2 to the first squared, right? We're doubling that exponent. And so that's where we get that. This is how that works. And so what I'm going to try to do is try to get something with 3 to the 2x plus something with 3 to the x plus something equals 0. So think of this like a times x squared plus b times x plus c equals 0. Right? So 3 to the 2x is our squared term, and then we'll end up solving from there. So that's the big picture. So now I'm going to show you how I need to get this done. So I can't have 3 to the 2x plus 1. I need it to be 3 to the 2x. So what does this plus 1 really symbolize? It symbolizes that we've added one additional multiplication of 3 onto it. So this right here can actually be written as 3 times 3 to the 2x, right? Because the plus 1 is just multiplying by 3 one additional time. So if I take the plus 1 off and throw it out to the front, I've accomplished that. If this seems strange, trust me, it is. The minus 18 remains, and we have here our 25 times 3 to the x. Well, now I'm going to rearrange this to get it like that ax squared plus bx plus c form. So I'm going to have 3 times 3 to the 2x minus, I'm going to move this over, minus 25 times 3 to the x minus 18, and that will all equal 0. So this is the equation that I'm going to be working with. Now, if you want to work with it in this way, you're absolutely fine to do that. One thing that some people like to do is to maybe think about this and this term as something else. We could think of it as something like, 3 to the y squared, where it's the squared term. But you might think of it as some sort of different letter in order to help get over some problem that you're having. And then you have, minus 25y, because 3 to the x, so again, like y is 3 to the x, and so y squared is the same thing as 3 to the x squared, which is the same thing as 3 to the 2x. So we're just replacing them. It just kind of makes it a little bit easier, maybe, to deal with. And then that's minus 18 equals 0. So at this point, you need to think about using the quadratic formula, or you need to use factoring, or whatever it is that you want to do. I'm going to factor. So in order to factor this, I know that I'm going to have two binomials. Okay, so imagine like our box. So I'm filling out the top and the side of my box. So one of them has to be 3y and one of them has to be y. The factors of 3 are just 3 and 1, so I know that that has to occur. And I need two numbers that multiply to make 18 that overall are going to subtract or add up to make negative 25. Now, if you do the quadratic formula, you'll get the same information. So if you want to use that, please do. But this should be minus 9 and positive 2. As you see here, 3y times y makes 3y squared. The outside, this would make negative 27y, which I knew was really close to negative 25, but then remember I add 2 back, and so that's where that comes from, and then the positive 2, this makes negative 18. So it does work. So at this point, that is 0 or that is 0. That's because I've turned it into multiplication. Either 3y plus 2 is 0, or y minus 9 equals 0. So as we continue, so here if we solve this equation, we would get negative 2/3, and we would get y equals 9 for this. Now, we're not done. I know this seems like a long problem, but we're not done, right? We've solved the equation as best we can, but we remember how we converted up here at the top. We converted our 3 to the 2x to y squared and our 3 to the x to y. So now we need to go back and say, okay, well, we know this. So now we go back and say, okay, well, 3 to the x equals negative 2/3, or 3 to the x equals 9. Right here is an interesting conversation to have, because you may say, okay, I can figure this out. Well, there's no exponent that you can think of that can take a positive number and make it negative. So there's no solution to this one. This is NA. There's no solution to that. Now over here, we know that 3 to the x is there, and we know that 9 is the same thing as 3 squared. So we can see here that x would be 2. Now because the other equation doesn't have a viable solution, the only answer to this equation is 2. X equals 2. Now it's a long equation, but think about this at the beginning. If you see these multiple terms, and especially if you see like 2 to the to the 2x and to the x, this is a type of way that we can solve the problem. We can think about it quadratically, and we know how to solve quadratic equations. We just kind of went through a whole unit on it. So this is a complicated type of problem, but it's very much about paying particular attention to what it is you're solving for, which again is x, right? You're solving for x. And so in order to get that, we think with a quadratic formula or with factoring, and we go through the problem like we did to find that x is 2.